إنك تعلم ما نخفي وما نعلن وما يخفى على الله من شيء في الأرض ولا في السماء. الحمد لله الذي وهب لي على الكبر إسماعيل وإسحاق إن ربي لسميع الدعاء. رب اجعلني مقيم الصلاة ومن ذريتي ربنا وتقبل دعاء. ربنا اغفر لي ولوالدي وللمؤمنين يوم يقوم الحساب. صدق الله العظيم.
Jazakallah. Today is the third and the last day of the 3 days seminars on HPC, ANN, and data visualization. Topic of today's talk is data visualization. This will enable participants to learn about the basics of data visualization, its origin, and the relevant information. Now I invite Honorable guest speaker, Dr. Farooq Alawi. Please, sir.
Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum. Thank you for the final day of the talk. And we hope to wrap up today from the previous 2 days. And I've tried in these 3 days to give a common theme. And, in yesterday's talk, we were referring to the material of the first day and so on. So we hope to repeat today some of the material from the first and second days as much as possible. Now, typically on a subject like this, data visualization, there is a lot of software involved. And, one would expect to be introduced to the workings of the software and, how to use it and, how to prepare data for usage by such software. But because this is a 1-hour introductory talk intended for undergraduate level, I'm not going to do that. I will mention the software by name. What I want to do instead is I want to discuss the ideas behind data visualization as a subject in its own right. Okay, so as you'll see, it has aspects of multiple disciplines. Going back to what we said in the first day, everything is multidisciplinary these days. So it will have aspects of art or aspects of science, aspects of a few other subjects as well. And hopefully you will walk away from this lecture with an appreciation of that. Okay, so this is a summary of what we hope to discuss, 4 main topics. So I'm going to ask a simple question first. Picture is worth how many words? Then we look at the art of effectively communicating science, because when we do data analysis, data visualization, there is some scientific element to it. And your job as somebody who's presenting this information is to be able to present that effectively. So the audience, the person who's listening and reading about. So the audience is then able to comprehend exactly what your message is. Then we'll talk about the analytics revolution. Data analytics is a big subject which has really come into being in the last decade or so. We'll see that this is an area where tremendous amounts of growth continue to be made. And then finally, we'll ask a simple question: is it art or is it science? So going back to the theme of being multidisciplinary. Okay, so famous Chinese proverb. Anybody here read Chinese? No, I was hoping somebody would, because I can't read Chinese. I was hoping somebody would actually read this, but apparently this is supposed to stand for this phrase here: pictures worth 1,000 words. Everybody's heard of this phrase, right? I imagine, yeah. Okay, but can we verify this statement? If you take this statement literally, is it really the case that picture is worth 1,000 words? Maybe it's worth 100 words or 10,000 or something else. Anybody ever think about it like this? Yeah, you have. More than okay. Okay, so before we can think about this question in this literal manner, we need to ask another question, which is this: does it even make sense to compare visuals to linguistics? Because when you say a picture, that's visuals. when you say 1,000 words, that's linguistics. Two entirely different areas. So we should really step back and ask, does this even make sense to ask a question like this in the first place? Okay, in order to answer that, let's analyze the brain, because all this the answers to these questions lie in our brain, in our understanding of things. So we talked quite a lot about the brain yesterday. We saw that the brain has different regions specialized for different tasks. So what are those regions which are specialized to these two things of visuals and linguistics? And what we find is that if you look at the language and the reading ability of the human mind, it's actually concentrated in this area here. The green bit and the blue bit here, of which this little part here is known as Wernicke's area, and this is where comprehension, written and spoken language is understood by the brain. Okay. Then we also have this thing called Broca's area, where language production happens. Okay, so if your Broca's area is actually functioning properly, you should not have any difficulty picking up a new language, for instance. All right. Okay, so that's the linguistics part. What about the visual part? So the visual part, in comparison, is something which stretches all the way here at the back, right? So remember yesterday I mentioned that visual processing happens at the back of the brain, and that's exactly what this is. The entire area at the back of the human brain is known as the primary visual cortex. Okay, and it starts off here right to the back, and it splits up into two pathways. So there's a dorsal pathway here where the question is answered whether there's a where or a how of a moving object. So this is basically picking up some kind of motion of an object along the dorsal. And then you have the ventral pathway, which is basically identifying an object. What is the object? So when you put this together, what you have is a full visual object recognition system. The first part, the ventral path, says, what is the object that I'm looking at? Do I recognize it? And then the second part, the dorsal one, says, is this object moving? And if it's moving, where is it moving? Okay. So what I want you to concentrate on is this, that look at the size of the brain, which is dedicated to vision, and compare it to the size which is dedicated to language. You see the difference between linguistics and visuals? So is a picture worth 1,000 words according to the brain processing? It makes sense, right? Okay, so what happens once all that processing happens? There's something called cognition. Cognition is basically the process of acquiring knowledge and understanding, because once you do all this processing of vision and linguistics and whatnot, right, it's meaningless unless you're able to comprehend what that processing is telling you. So the eyes and the ears, your ability to read stuff, your ability to hear stuff, right, are basically sensors connected to the brain. They go into these pathways that we discussed, right? There the information is decoded, right? And it doesn't just stop there. It goes on into the areas of the brain which are specialized for cognition, for ability to understand and comprehend. And those areas are huge. We find that there's this frontal lobe region in the front of the brain where problem solving and thinking happens, right? And this explains why, God forbid, somebody has an accident, they get injury on the front of the brain, they lose their ability to think. Okay, and then you also have the parietal lobe here, which is this huge area, almost 1/3 of the brain dedicated just to attention. Put these together and you have the ability to comprehend stuff. Because to comprehend stuff, you need to be attentive to it first, right? Right. So hopefully you understand that, this taken together, the frontal and the parietal lobes, and if you look at them, they're taking up nearly half of the brain here, is dedicated to nothing but just to cognition, the ability to comprehend. Okay, so this is a kind of high-level view of, or a philosophical view of, what we mean by cognition. So imagine that, at the bottom of this pyramid here, you have the data, which is the world surrounding us. Okay, that data is a source of information. Okay, and that information then leads to knowledge in the human brain. Once you have knowledge, then you can begin to understand subjects. And once you have understanding, the ultimate thing at the peak is wisdom. Wisdom doesn't come to everybody. It comes to only few, those who think about things, right? Okay, so some empirical observations. What do I mean by empirical? What does the word empirical mean? Anybody? Numbers, yes, numbers which are observed by experiment, yes. Okay, so here are some interesting numbers which people have, scientists and engineers and all sorts of psychologists, people, they've looked at all this data and they've come up with these very interesting numbers. The 90% of the information transmitted to the brain is visual, which makes sense because, a great part of the human brain is dedicated to vision. So, the majority of the information that comes in, even if it's by reading or looking at a movie or whatever, it is visual first. Okay. Humans can process images 60,000 times faster than text. That's pretty impressive because computers can process text pretty damn fast. Okay, so here the human brain can still do it even faster. 70% of our sensory receptors are in our eyes. That basically corresponds to what we just said about the importance of, or the domination of vision over the other senses. And 65% of people are visual learners, right? Now that's an interesting statistics because, when you want to learn something, the ratta culture, as you call it, right? You repeat something linguistically, right? You hear it repeatedly and, it sticks in your brain. Why do you think then, is it fair to say that 65% of people are visual learners? Any ideas?
First, coordination between the two lobes of the brain.
Not really, no. No, it's to do with the fact that learning and cognition, if I step back a bit, learning happens all over the brain. It's not just specialized in one area, okay? And when you repeat something through an audio or a speech signal, right, you basically affect the rest of the brain, not just this cognition area, right? So that's why it's said that, if you want to learn something fast, repeat it using your tongue, your mouth, right? But at the same time, learning happens first to the eye. So that's why we say that 65% of it is visual. Okay, right. Then we have this other statistic here. Only 10 to 20% of written or spoken data is remembered. 65% information is remembered when it's presented visually. Remembering things is an entirely different part of the brain's function, which is to do with memory. There are many kinds of memories in the brain: short-term memory, long-term memory, semantic memory, etc., etc. Okay, and we looked at the part of the brain which was responsible, the Broca's region, which is responsible for language. That also plays a part in how much memory you retain when you hear something. Okay, so again, going back to the question, how many words is a picture worth? The answer is priceless. Okay, you can't put a value on it. If it's priceless, if it helps you to understand stuff, it's not just priceless for its own sake. Okay. So it's all about cognition. It's about understanding. If you see something and it's worth 1,000 words or whatever, right? It's priceless if you understand it. Okay, something to note. This is saying nothing about the accuracy of the message that is being conveyed, just the information content, right? So let's distinguish between the information content, which is this priceless information that you're receiving, and the accuracy of the information. The accuracy of the information has to be determined through other means. Right. So when you hear a piece of news, go out and verify it somehow, but verify it through other means, not necessarily just because, you've read it somewhere. So we need to look at the whole picture for accuracy. And accuracy is a fundamental part of information processing, as you'll see. So continuing with this theme of looking at the whole picture, I showed you this Chinese thing here, right? You might notice that, at the bottom, I've actually cut off a little bit here. All right. So I'm going to show you the full picture now. Read that very carefully. Chinese proverb says one picture is worth 10,000 words, not 1,000. Okay. So I've just shown you information which I obtained through other means, right? And you have to ask yourself, where did this image come from? It actually comes from a 1920s advertising literature by an American advertiser. So here it is. There's that little part here that I took it from. Okay. The guy's name was Frederick Barnard, right? He was one of the first people to have a scientific view of advertising. And what he did here was this is a publication in America which was concentrating on the advertising industry. So this was his second attempt at coming up with this phrase that a picture is worth 1,000, 10,000 words, right? His first attempt was actually this. And if you, unfortunately, I don't have a very clear picture, but if you read it carefully, it says that one look is worth 1,000 words. And in the first iteration, what he did was he came up with this phrase and he said this was a Japanese proverb, not a Chinese one. About a year or two later, he published another article where he said this was now Chinese, and he upped the number of words from 1,000 to 10,000. Okay. What have I just done here? I've just shown you that the accuracy of information, which you took to be granted until now, if I had said that this was Chinese, you would have believed me, right? Okay. Right. But I've shown you some background information because I did a bit of research, right? And what I've done here is basically verify the accuracy of the information that I presented to you. Now I've clarified it, so hopefully you'll not catch me for telling a lie earlier, but I hope to make the point that always verify the information you get. So moving ahead with the importance of accuracy, you can define accuracy as the ability to represent how closely a given data set comes to its true values, right? So there's an absolute universal truth, and there's our understanding and our representation of it, right? The two do not necessarily match. Even if you're the most truthful person on earth, right? You may not have an entire understanding of the situation you're looking at to ascertain what the actual universal truth is, but you do your best. In the absence of accuracy, what happens? You end up with falsehood, which can cause catastrophic results. A good example of this is the French rocket program, Ariane. A few years ago, they tried to launch this set of satellites into orbit, and they had very good safety record, by the way. The French, 99% of the times they launch a satellite, it goes into space. This time it failed. I think it was the Ariane 4, if I remember correctly. And the reason it failed was because there was a little bit of falsehood in the information that was being presented to the computers. This was a catastrophic result because it cost millions of dollars to try and launch a rocket, right? Okay, but it can also lead to loss of life and stuff. So when you present information, one of the key motivators for presenting accurate information is to make sure that you don't cause any harm, because falsehood does cause harm. Okay, so falsehood can be caused by bad equipment like the French Ariane case, poor data processing, human error. As humans, we all make mistakes. Nobody's perfect. How would you mitigate human error? See, in terms of machines, right? Machines are capable of judging each other. You can write a software subroutine which basically checks another machine's output and verifies it. How would you do it in the case of humans? How would you minimize human error in a critical domain? Any ideas? Training is one way, yeah. Set a benchmark, exactly, yeah. But the best way of doing it is basically through consultation, right? If you have instead of relying on just one person, no matter how much of an expert he may be or how truthful he may be, consult with others. Because when you consult, somebody else will bring a new perspective or a new insight into whatever you're saying, and that might just change the course of your project or your history. Okay, and finally, we have this absence of accuracy, the ability to deliberately misrepresent the truth. We were just talking about this, Dr. Sauer. It's interesting. This is increasingly used in fifth generation warfare and stuff like that, right? You don't have to go and send an army to find somebody else. You just spread misinformation, fake news, get people to react to that. Okay, this is an increasingly challenging problem for everybody in the age of universal internet access. And there are no easy ways to deal with this. Here's an interesting book. It was first published in the 1950s, How to Lie with Statistics. Okay, so first of all, we have an intrinsic understanding, hopefully, that when you have large data sets, the only way you can handle them in any meaningful way is through the use of statistics, right? You work out the mean, the variance, covariance, etc., and all these other wonderful things that we have in stats. And that allows you to see the bigger picture from a huge bunch of numbers. But those those pieces of information can also be misused, right? You can deliberately misinterpret what statistics is telling you in order to do, for instance, fifth generation warfare. Or you can do it by accident, of course, but most of the time, if it's done deliberately, it's because of somebody hoping to achieve a specific purpose with that lie, with that falsehood. Interestingly, this is supposedly Bill Gates' favorite book. So, next time you hear from Bill Gates, keep that in mind. So we'll conclude by saying that it is critical to maintain accuracy in data science and data visualization as much as humanly possible, right? So this has to be an ongoing effort. If you're a data scientist, if you're trying to present data through some clever visualization software, try and make it as humanly accurate as you can. Okay, so let's look now at the power of visual information. So we've talked all so far about the domination of the visual processing of the human brain against the other kinds of processing which happens. Just to give you an example of the power of visuals, let's look at this data set here. So here we have an Excel spreadsheet showing the number of cars which are used for different for driving in a town in a city, right, over a number of years. So we start, I don't know if you can read it properly, but basically this is starting in 2010 going up to 2020. And this column here is basically telling you how many cars are used in city and how many are used in town. And the final column is telling you the grand total of cars. Okay, if I just give you this list of numbers, right, you will struggle to make some sense of it. Okay, you will say, okay, well, I can see that 18 cars are used for city and 14 for the town in 2010, and then you'd go through it row by row and say, okay, so this is happening in this year, this is happening that year. But do you get a bigger picture of stuff? Yes or no? Now let's try and use Excel's graphing function to visualize this. What we have here is in orange, the town, the cars which are used in town, and in blue we have for the city. So the first thing which strikes you about this, that far more cars are being used for driving in the town than they're in the city. Now you could have figured that out just by looking at these numbers, right? But this is like instantaneous. Here you would have to read the numbers and try and decipher them one by one. Whereas here, one glance and you know exactly what's happening. So consider the following. What is the information content in both? In this table and in this graph, are they presenting different information or the same information? Exactly the same. Which one conveys greater understanding? Right. So a picture is worth 1,000 words, maybe, or more. Okay, so I understand a lot of you guys are final year students. As a student, you must have done this in your life. make a graph in Excel. You do Control V and C and copy some nice looking graphic into Word. Save it as a PDF, email it to your professor, and then you say, thank you, Allah Mia, assignment is over. Okay, you've done it, right? All right. How many of you have done this? You've considered that the assignment will be read by a person who's a human being. The professor is a human being, he's not a machine. You've tried to make your results easy to read and understand. Okay, you just want to get the assignment out of the way, right? You don't care if it's easy to read, because the guy who's reading, the poor professor, right? He's going to scratch his head. What is this guy saying? You've thought about making the presentation enjoyable and memorable. I'm hoping this presentation is enjoyable and memorable, right? Okay, effective communication is the key to all of these, right? Effective communication is a subject in its own right. It's studied at a degree level, right? It's used a lot by journalists, but it should really be taught at the undergraduate science level, because science is one of the most difficult things to communicate. So there are 7 rules for communicating effectively in public, right? So we'll go through them one by one. Clarity is the delivering a message. Objective is what is the purpose of the message. You have to understand the receiver, the person who's reading it, right? You have to understand them. Remember, they're like an audience to you. They're like a customer. So you have to somehow try and get into their mind. What if I put myself in this guy's position? What would I be looking for? You should have consistency in your message. Don't try and say something and then contradict it. You should have completeness. Make the message as complete as possible. You should have feedback. So I'm asking you a question. That's feedback, right? Okay. And you should be very mindful of the time. How much time do I have, by the way? Okay. All right. So let's actually analyze this a bit more. Let's look at the first one, clarity. Make your message clear, make it simple, straightforward, make it concise, to the point, avoid ambiguity, know and understand the audience. All right. Next one, objective. What is it that you want to achieve? Know the outcome before you write a report to the professor. Focus on something, right? Know what is expected of you as a student, right? Set a direction. And you should know the reason to communicate. Is it because you're transferring information to somebody? Is it because you want them to take action? Is it because you want them or yourself to make a decision? Next one, understand the receiver. Seek to understand first and then try to be understood yourself. What is the receiver's requirements? What is their custom, their timing, environment? Because, remember, you're treating the audience like a customer, right? If that audience happens to be from another country, another culture, you have to present the message somewhat differently so that they understand it better. Consistency, there should be no variance and no confusion in your message. Completeness, the message has to be communicated, must be adequate and complete. Feedback, having a question answer session is good for two-way communications, and you should always try and get feedback to get confirmation or understanding from the receiver. So if I ask you something and I say, do you understand? You guys nod your heads, then I know I'm satisfied that, okay, I've done my job, now. Rest is up to you guys. Time, pay attention to the length of communications. When to communicate is also a critical factor for the success of communication, because the wrong message at the wrong time would go nowhere. Okay, so that was like a degree level way of looking at communication science. But here's a simplified version for people who are doing data visualization, right? So we start with identifying. This is really important, right? So when you start creating a beautiful data graph, whatever, right? First thing is identify your audience and your context. Who are the stakeholders? What do they need to know? What is it that I'm trying to tell them? Second thing is find the story in your data. You're like because you're treating the audience like a customer base, right? Tell them a story. This is what people in advertising do. They make a story out of the message that they're trying to promote. You're doing the same thing as a data scientist, okay? Think of the project not as a project, but as a story you're telling. So in the story, what information do you have? Are there any identifiable patterns, trends, surprises, relationships, success or failures? Something that you wish to highlight. Once you have these, once you know the audience, once you know the story that you want to tell, then you build your visualization around that. You can sketch it out first on paper, okay? If it makes it easier. Choose the right type of chart for your data, simplify it. Use pre-attentive attributes to highlight your story. So pre-attentive just means that, before you go into the depth of something, right? Take a very coarse view or a rough view of it first. That will help you to get the deeper understanding later. And then finally, disseminate, share, and use your information. So this is a bit where you print out your PDF and send it to your professor. How will this visualization be used? What is the ideal format for it? What are good data visualization which ensures that data is read, understood, and used for effective decision making in an appropriate manner? Okay, so any questions so far? No. Okay, right. Let's move on. So the analytics revolution. So data everywhere. This is the title of a very famous report which was published in The Economist more than a decade ago here, where they started off by saying this: information has gone from scarce to super abundant, which brings huge benefits but also causes big headaches, right? And they had this chart to back their stuff up. So they said that this was a prediction that remember this was done in 2010. So they looked 1 year ahead. They said by 2011 we'll have a forecast of so much data, and this is in I think it's in exabytes. Yeah. Okay. What is 1 exabyte? 10 to the 18 bytes. So what is the cause of this data explosion, right? So remember, this is like 11 years ago. So where do you think the data volume stands at today? I have a slide of that later on. But you expect it to continue increasing exponentially, correct? So what is causing the data explosion? First of all, increasing market access, acceptance, and affordability of digital technology. This is the prime driver behind the explosion in data. And secondly, we have new emerging technologies which have come into being in the last decade since this graph was done. For instance, an increasing use of social media accounts. Okay, people had mobiles more than 10 years ago, right? But the use of social media was a lot less back then than it is today, right? So every time you post something or you like something on Facebook or whatever, you are generating data, right? Okay, so by 2025, there is, so we also have emerging technology like IoT. People have, hopefully people have heard of IoT, in Internet of Things, right? So this is, the idea is basically that, small devices, the size of your thumbnail will be embedded all over the environment, in your clothes and your, in your walls and whatnot. And they'll all be generating data and, communicating with some central server, which will hopefully use that in a shamelessly money-making way, right? That's the basic idea. But there are a lot of ethical issues involved with that, but let's not get into those. So by 2025, there are expected to be 75 million Internet of Things devices in the world. Okay, and by 2030, 9 out of every 10 people aged 6 and above could be digitally active. So what does that tell you? That at the moment, we are still about one decade away from 2030. At the moment, right, the majority of people who do not live in cities, right, they may have cell phones, right, but they're not necessarily digitally active in the sense of having, internet accounts and social media accounts and stuff like that. But that's expected to change. How much data is created every day? Nobody knows for sure, but we can make some intelligent estimates, right? So some people have done analysis and they said the amount of data in the world is expected to be 44 zettabytes at the dawn of 2020. So 1 zettabyte is like 3 orders of magnitude greater than the exabyte, which is so it's 10 to the 21 bytes. And in 4 years' time, the amount of data generated each day is expected to reach 463 exabytes globally, every single day. So the big tech companies store at least 1,200 petabytes of information. So a petabyte is like 3 orders of magnitude below an exabyte, which is what, 10 to the 15? And all this generation of data has led to this common phrase that people are saying data is the new oil, right? Now, oil may be dying off as an industry because we see electric vehicles coming on the market and whatnot. But for several decades, oil was the single most successful industry in human history. It still is, by the way, right? Because electric vehicles still outnumber, the petrol vehicles outnumber electric vehicles by a factor of, several hundreds to one. I think the figure quoted by Elon Musk in a talk I saw recently was about 3% of all global vehicles are electric. The rest 97% are petrol. So if data is the new oil, you have to ask, how does one extract this oil? How can we commercialize it? Okay, and the answer is through data analytics and data visualization. So visualization is also known as the last mile of data analytics. Now, the phrase last mile comes from the telecoms industry. Has anybody heard of it? Yeah. Okay. So the idea is this, that you have these, you have fiber to the home and you have internet to the home and you have your wireless connection at home. But that wireless connection and that fiber to the home is connected to some citywide metropolitan area network, right? And that final connection from the metropolitan area network to your home is known as the last mile problem. It's the most challenging of the problems because you have to go through cities and streets and start digging on streets to make sure that this wire reaches your home. Okay, so the last mile is the most challenging, and visualization is also the last mile of data analysis because it's the most challenging of the lot. And if you're a pure scientist, if you're an artist, maybe it's a bit easier for you. So what we are seeing is an increasing use of data analytics tools that combine statistical analysis with sophisticated graphical capabilities. So if you look at all the data analytics tools which have emerged in the last 10 years or so, you can break it down according to this hierarchy here. So you take data analysis as the root, and then it splits up into programming language, which are specialized for data analysis and visualization, and applications. So looking at applications, you have the usual Tableau, Excel, Power BI, Click, and all sorts of other startups are emerging who are trying to launch their products. And of course, you have cloud-based systems, which are of increasing importance. Looking at programming languages, starting from the right, you have SAS, SQL, been around for decades. SAS is a very well-known statistical analysis package. There are universities which are doing entire degree courses on just SAS programming, surprisingly. SQL, everybody knows SQL, right? How to access data in a relational database. Then you have R and MATLAB, which are functional languages because they allow you to do interactive calculations and interactive displays and stuff. And then you have Python. I've treated Python as an entire family of products because it's now not only the dominant programming language for data analysis, but it's also the one with the most number of tools. So, has anybody actually worked with Python here? No? Surprising. Okay. Okay, so you have a whole bunch of support tools in addition to Python, the language itself, which allows you to do all sorts of stuff, from data analysis to visualization to speech processing, you name it. There's probably a library for it in Python. Okay, data dashboard. Anybody heard what a data dashboard is? The idea of a dashboard actually comes from the car industry. Obviously, a dashboard is basically the driver having a compact view of what's going on around in the vehicle, how much fuel he has, what speed he's going out, how much distance he's covered, etc., etc. And we borrowed this term from the auto industry. So here's an example of a data set, which appears to be very neatly laid out. Somebody has put a lot of effort into presenting this information here in a very compact form. It's not just a bunch of columns like we had earlier for the city and town cars, right? So somebody has put these separate regions here, and they've bothered to put labels here and identify the different bits of data. In the old days, this would have been sufficient to write a report. Nowadays, with these amazing tools that we have, we can compress all this and present it as a dashboard. Now, the dashboard is not just going to present this information to you, but allow you to play around with it, just like a spreadsheet does. In a spreadsheet, you can do so-called what-if analysis, right? I have a row, for instance. If I make this one change, how is it going to affect my bottom line, for instance, right? You can do exactly the same with these data dashboards. So with this data set, somebody was able to generate this dashboard. Now, isn't that a lot prettier to look at? A lot nicer, right? A lot more powerful because you can go and play with these values here and look at the result immediately. So when you do data visualization, your objective should be to present the data ultimately. If it's not meant for a report, if it's meant for live usage, always make sure that it ends up in a data dashboard form. Now let's observe the following. So we're coming to the final part of the talk. Is it art or science? So we observe the following: that analytics requires modeling, testing, mathematical analysis of large data sets. I think everybody can appreciate this. How one chooses to display this information requires attention to both artistic and technical detail. And you need both of these in order to correctly, beautifully, and simply visualize the data. Any useful information hidden in the data can be misrepresented due to lack of technical understanding or incorrect. So remember, there's a deliberate effort to introduce falsehood into data, but it can be accidental as well, right? So whenever you're not sure, make sure that somebody else checks your data set and your visualization to make sure that it's as accurate as possible. And therefore, we conclude that data visualization is therefore both an art and a science. It's not one or the other. It's a mixture of both. So this is the final slide, tips for doing some great data visualization. Keep these in mind. A good graphic tells a great story. So, try and get your artistic abilities up if you if you haven't got any. There are courses you can do online these days for beautiful graphics. That might help. Occam's razor is a well-known philosophical phrase. It says that everything should be made as simple as possible, but no simpler. So if it's as simple as possible, don't try to make it as any more simpler, because then you're going to start losing information there. Use the right tools for the right job. Don't use Power BI if Excel will do the job equally well, right? Do not overkill. And talk is cheap, because this is all about presenting information. You remember, it's all communication. You're communicating some information, right? Talk is cheap, but keep in mind that electrons are even cheaper. Electrons run the computers, so use them freely and wisely. Thank you. Questions?
Assalamu alaikum, sir. So my question is regarding data mining and data visualization. For example, if we have already visualized the data and it's in the form of some graph or anything that is visual. And can we mine that too?
Data mining is different to data visualization, right? Data mining basically means that you have a large data set, okay, and you're trying to look at insights into that data using tools, non-standard tools usually, like neural networks, for instance, is a good way of doing it, right? In order to see patterns and hidden information which is not so obvious, that is data mining. Visualization happens after that. Once you've understood and extract this hidden data or hidden patterns, you need to present that. So visualization is about presentation. One is about extracting information. The other is about presenting it. So they're two different things.
Assalamu alaikum. This is Kashif Hamid from IT department. So my question is, you have told about Python language. So what makes Python language more data-oriented language as we have other languages available in, that is Java and other? What makes it more data-oriented?
Okay, so you need to distinguish between compiled language and functional language, right? So Java, for instance, is a compiled language. You write code and you're compiled to binary code and it runs on a computer, whereas the functional language is much more interactive. You put in some information and immediately it's interpreted, it's not compiled. There's a difference. Okay, so the interpreted value is then generating an answer, which is then sent back to you. And then you act on the next result and so on. So that's the primary difference. The reason Python took off in a big way was primarily because it was, first of all, easy to learn. And when this whole data analytics revolution began about 10 years ago, there was R and there was Python. There were these two languages which were dominant, but Python simply took off because more people were using it freely. The libraries were better, and it just built on its success after that. R is still being used very heavily, but Python is the market leader.
Assalamu alaikum. This is Tayyib Bukhar from CS department. Sir, my question is, there is in the case of text mining, textual data.
Textual data, yeah.
There is a lot of work has been done for English language, as it's but there are many other languages like Urdu, Arabic, Persian, and other languages. Can we analyze this language like multilingual languages? या क्या हम इन सबको इकट्ठा एनालिसिस कर सकते हैं?
Okay, I can see why you're asking this question, but it's not really directly related to data analysis. But the idea of using languages other than English is something which has been worked on heavily. When was it? About 3 decades ago, they came up with this so-called Unicode standard, which basically allowed people to basically represent all the characters of all the human languages using a 16-bit code. So previously we had the ASCII code, which was 8 bits, which was English only. It couldn't represent other languages. So the Unicode consortium was formed by the computing industry. They came up with a 16-bit version called Unicode, and the Unicode basically, it's been frozen in time for the last 2 decades. Nothing is happening on it because it's complete now. But it allows you to have all the characters, as I said, of all the languages which are spoken by humans. So once we made that step, right, the next step is, can we do some text analysis? Yes, you can. Absolutely.
Thank you.
Thank you. We spoke about different parts of the brain where we store text or the words or the pictures. So my question is, where do we store our beliefs, fears, or phobias? Or in which form, either they're stored as visuals or how they're stored, and which part of the brain they're stored?
Yeah, I don't remember all the regions of the brain, but there is a region which is specialized for these belief systems and whatnot. Yeah, sorry, I don't know the brain that well to be able to answer you directly.
I believe nobody knows brain that well. So.
No, the brain is one of the most complex things that we study. It's still not fully understood. And it's the problem is, of course, that it's purely an experimental science. And of course, you study the brain only after somebody has died. So somebody has to be dead for you to make research here. So that complicates things a bit.
Thank you very much, sir, for this wonderful talk. So we have multiple ways to visualize the data, and there are various types of data. So
Yeah.
is there a rule of thumb that if we have this type of data, it should be visualized in this way?
No, not to my knowledge. No. I think what you're asking is, does the data create its own visualization automatically? No, it doesn't. It doesn't. It really depends. Going back to what we said earlier, you're telling a story. To tell the story, you have to know your audience, and you have to know what is it that you're trying to inform them of. So the data by its very nature is not going to tell you that. That's something you as a human being have to decide.
So the second question is, we have talked about, or we have seen that there are zettabytes of data generated every day.
Yep.
So, I mean, how can we certain the integrity of this data or the provenance of this data before using
Yeah.
this as a fact or presenting this as a fact to someone?
Yeah, that's not an easy problem to solve at all. It's highly challenging. I mean, how do you verify the truth of data? Just by looking at it, you can't. You have to go to the source, and once you go to the source, then you have to assess whether or not that source is reliable enough for you to believe what is being generated in the first place. So a lot of the times the source simply doesn't exist. I can think of the best example probably from Islamic history, when the hadiths were compiled. Happened 2 centuries after the Prophet, right? How did they do it? We know the Sahih hadith, right? I mean, so they had an even more challenging task than us, because there was no computers in those days. Okay, but they did it by looking at the chain of narration. Exactly what we were discussing earlier. That look, you go to the source, right? If that chain of narration, if the source is verifiably true, and the next one is true, and next one is true, then then there's a high probability. You can't say with certainty, but there's a very high probability that everything else is true.
Sir, you described well about data visualization and data analytics. As for my understanding, data analytics is the combination of information visualization, machine learning, feedback, and etc. But nowadays, it has become the necessity of a common businessman, a shopkeeper,
Yeah.
In winter, who wants to know that what design articles could be more saleable in winter. He cannot do this directly because he has no knowledge about data analytics, machine learning. And if he goes to the industry, he must pay cost and time.
Yeah.
Is there any other solution?
No, there isn't, unfortunately. I mean, but
we can facilitate a common person. We can facilitate a common shopkeeper to let it do it by yourself.
Yeah, see, the great majority of people out there will simply not be able to do this. Obviously, we know this, right? So you need specialized people, and specialized people, when they come to a task like this, they're not going to do it for free, right? You have to pay them. But it's looking at it from the flip side. It's an opportunity for startups. If you guys want to start something and start offering your services to the local shopkeeper, go ahead.
In one of the previous slides, you showed us the tree of data analytics. One of the subnode is applications, and on the other side, there were programming languages. So my question is, when we have to use the ready-made tools for data analytics and visualization, and when to use the programming languages?
That depends on the nature of the data, the kind of information you're trying to generate. There's no single answer to this, right? It may turn out that you may need a mixture of both. You may need a bit of information to be presented in Excel or Power BI or whatever, but some of it cannot be done in those tools. So you have to use Python to perhaps pre-process data and then make it usable by these other applications. So there may be a whole chain of these combination of these tools that you need. So it's task specific. It's not just one rule for everything.
Sir, as we have a lot of data and big data these days, there is one issue about data protection. So it is very easy to for theft of data, that our data is being theft, even our private data by social networks and these type of platform is being theft. So how we can protect our data from being theft?
Okay, this is a very fascinating question, because a lot of the data theft happens simply because you let it happen. Do you really need that Facebook account and start clicking on likes because it's all being recorded? You're giving your data away freely. So at a personal level, be careful. Don't interact with these social networks too much if you are careful, if you're serious about protecting your identity and your information. But there's another level. There's a society level, right? Governments, especially the European Union, they've done a great job with this GPDR, the General Protection of Data Regulations. They have a set of laws now in place, which has been copied even, I think, by the government here in Pakistan, which basically makes it obligatory for these big tech companies to allow users, individual users, to access the data and verify that it's true. And if you want, you can actually force them to remove it legally. So it needs protection at the government level. It also needs care and protection at the individual personal level. But you're right. I mean, this is a big challenge, and one should never, ever trust a third party with personal information if you can help it.
Assalamualaikum.
Also.
So whenever we talk about data visualization, it's usually said that pictures worth more 1,000 words. And always we refer to graphs, that graphs are better to represent a list or table as you shown. What are other powerful ideas to represent the data other than the graphs? Because I have seen many articles on this, and everywhere only graphs are mentioned, that graphs are a powerful tool. What are the others? And can you refer some study material over that where we can find different options to visualize the data?
Yeah, in fact, graphs is not the only way, but it's the most convenient way. It's the one everybody's familiar with, because you study that when you're at school, basically, right? You study how to interpret graphs, how to construct graphs. But there are many other ways of representing data, and people are coming up with all sorts of new ways of doing it all the time. So there are so-called scatter plots. There are data clouds and stuff. But I think I have one slide here which might be relevant. This one here. Look at this thing here. I mean, this is a bar graph, right? It's not exactly a graph, right? But I could have presented this in a pie chart form. That's another way of representing data, which is not a graph, right? I could have done it as a data cloud. I hope you know what that is, and so on, right? So there are many ways of doing it. It really depends on how you wish to present the information. But this is like pretty straightforward stuff. If you want to come up with your own way of visually representing information, there's a lot of scope for that. You should make the effort if you can do it. I've seen some examples which are they look very nice and pleasing, but you struggle with what is the information that is being conveyed here. So if you come up with your own way, make sure that it's easy to understand. It tells your story very well.
Assalamu alaikum. So my question is, you have presented that 90% of the learning of our brain is from the visuals in one of the slides, right? Sir, is there any human behavior role in this figure? Like a newborn is always compelled to learn by the visuals. He has no other option to learn. So he's always compelled to learn by the visuals. So we compel the newborn in a way that he's not he's moreover compelled to learn by the textual or other somewhat other.
Okay, I don't think you can compel a newborn to do anything. That's okay.
1 to 4 age. For 1 is 4 years.
Right. Yeah, but in fact, your statement is not entirely accurate. I don't think newborns only work visually. A lot of smell and touch is involved as well. They respond to that as well very well, right? So it's not just they respond to voice. Yeah. Okay. So I'm not sure what your question is, but that was a bad example.
Assalamu alaikum, sir.
Excellent.
So there is a question regarding if we have a images data as well as sensory data, audio data, as well as textual data, various types of data regarding one domain. And if we visualize the data, then how can we visualize this? If we have different types of data related to one problem, then how can we visualize this? Yeah. If we have, for example, if we have a data of a patient regarding his images, as well as his audio regarding his disease, as well as different tests regarding.
Oh, I see. So it's a question about the different domains of
Yeah.
representation.
Yeah.
Yes. If it's purely auditory, then you can perhaps represent it as a time series, because audio signals are based on time. Okay. If it's purely visual, you can probably go two-dimensional graphics or something like that, right? So again, it's one of those questions where you need to put in a lot of creativity from your own side. There's no single answer to these things.
Okay.
Thank you.
Thank you very much, sir. Ladies and gentlemen, we have with us today Mr. Aftab Ahmed, Director Citronics Telecom Solutions, a data analytics company. I request Mr. Aftab Ahmed to present the shield to our honorable guest speaker, Dr. Farooq Alawi. Sir, I request to come on the stage. Thank you, sir. Now I request the head Department of Computer Science and Information Technology, Dr. Nasir Naveed, for the vote of thanks.
Thank you, Asma. First, I would like to say thank you to Dr. Farooq Alawi for traveling all the way from Karachi to Lahore. So in the opening, Rector Sahib has already mentioned that this travel ended up by traveling by bus, actually, supposed to be by plane, but somehow Dr. Sahib made it to the virtual university. Thank you, sir, for 3 wonderful talks. We have learned a lot in these 3 days. It has opened us, or opened the, you can say, provided us the guideline to think into these directions as well. So I hope out of these talks, our faculty members and students, they will come up with some good ideas for research or for project or something like that. So thank you very much, sir. So again, arranging this seminar series on a short notice, it takes a lot of effort from our event management team, especially led by Dr. Salman, Saima, Asma. Thank you, the team, for arranging this seminar in a short time. And like always, we are backed up by our finance department for providing the finance to this event, and our technical team, which includes TV team, or the people from the VU TV, to have all the visuals of this seminar, and plus our ICT team, so providing us a platform, online platform to deliver this talk or to stream this talk online on the YouTube, and to all other janitorial staffs who cooperated with us for this successful execution of this event. So thank you very much, all of us. So I hope this journey will not end up here, it will start. So we will invite Dr. Saab for another time to come back to us and provide us talks with some other topics relevant to, of course, their domain as well. So, and I'm especially thankful to Aftab Sahab. We have already seen him so enthusiastic person. Okay. Sir Aftab Sahab was the chief architect of our 4 days hands-on data analytic workshop. So he's running a company of data analytics. He's a good grip on data analytics. So thank you, sir, for sparing time for today. So thank you, everybody. So hand over to sir.
Dear participants, this is the end of our 3 days long seminar series. We have arranged the tea for you outside the hall. But before moving for the tea, let's have a group photo outside the building by creating a visual memory. Thank you all.